Regression in machine learning is a type of supervised learning used to predict continuous numerical values. It works by modeling the relationship between input features and a target output. Hello everyone and welcome to the regression part of machine learning with Python. My name is Narendra Kumar Sharma. In this video, we are going to cover simple linear regression. Linear regression predicts continuous values by fitting a straight line that best represents the data. What is linear regression? So linear regression is a fundamental supervised learning algorithm used to model the relationship between a dependent variable and one or more independent variables. It assumes that there is a linear relationship between the dependent variables and the predictors. In regression, we try to calculate the best fit line which describes the relationship between the independent variables and dependent variables. It predicts continuous values by fitting a straight line that best represents the data. So here is the equation and we will look at the parts of this equation one by one. On the left, we have our dependent variable which we are trying to predict. On the right, we have our independent variable. Here we have B0, which is the y-intercept, also known as the constant. And B1 is the slope coefficient. We are going to use a simple data set. This is a simple data set with 30 observations and 2 columns. It has one feature, years, experience, and the dependent variable which we want to predict, salary. Each row corresponds to a different employee. Each employee has years, experience, and their salary. We will train our model so that for a given year's experience, we can predict salary. Let's go to our notebook and implement our first machine learning model. Let's implement our first machine learning model. First step is importing the libraries. We are going to import 3 libraries, which are NumPy, Pandas, and Matplotlib. Insert a cell, import NumPy as NP, import Pandas as PD, and import matplotlib.pyplot as PLT. Run the cell. Next step is importing the dataset. We are going to import salary_data.csv from data directory. We have already covered in detail in previous lesson how to load dataset and extract independent variables matrix and dependent variable vector. Insert a new cell. Dataset equals to pd.read CSV. Data directory salary_data.csv. Extract x dataset.iloc all rows, all columns except -1, last column, dot values. Y equals dataset.iloc all rows, last column, dot values. Run the cell. Check the dataset. Insert a new cell. Dataset.head. Run the cell. This dataset has 2 columns, years, experience, and salary. Let's print X and y, print x and print y. Run the cells, run print x. Now this is independent variable matrix. Run print y. This is dependent variable vector. So x is a matrix which has only one feature, years experience, and y is a vector which has salaries. Next step is splitting the dataset into the training set and test set. Insert new cell from sklearn dot model selection, import train test split. Call this function, pass x, independent variable matrix, y, test size, set it to 0.2, 20%, and random state, set it to any number. I'm setting it to 42. X train, X test, Y train and Y test. Run the cell. We have completed the data preprocessing part. And now we are going to build and train the simple linear regression model on the training set. Remember that the training set will be used to train our model and the test set will be used to evaluate it. Let's print x test and y test. Okay, before moving on to the next step, insert a new cell, print x test, insert one more cell, print y test. Run this cell, run print y test. Now next step is training the simple linear regression model on the training set. The first thing we will have to do is to import the class with which we are going to build the simple linear regression model. We are going to use a linear regression class from linear model module from scikit-learn library. Insert a new cell from sklearn dot linear model, import linear regression. Our model will be an instance of linear regression class. We are going to call this object model equals to, we can call it by any name. Now create an instance of linear regression. We don't have to enter anything here in parentheses. This line will build the model. Next thing we have to do is we have to train it on the training set. The method that we use to train it is called the fit method. Call the fit method on the object. It will fit the linear model on the training set. model dot fit. Now pass training data. X train and target values Y train. X train and Y train. X train contains the features and Y train contains the dependent variable vector. Run the cell. The linear regression model is created. Congratulations, you have built and trained your very first machine learning model. Next step is predicting the test set results. Insert a new cell. Ypred equals to model dot predict. We want to predict the results of the observations in the test set. Pass X test. Run the cell. Let's check Ypred. Insert a new cell. Print Ypred. Run the cell. Now compare this predicted salary with actual salary. Actual salary is this. So here we passed X test, this X test, okay, to predict. Method, first predicted salary, first predicted value in Ypred is this 1,15,790. So this is predicted salary, and actual salary is 1,12,635. Last salary here, actual salary is 57,189 and predicted salary is 60,189. Now next step is visualizing the training set results. Add a new cell. Now we will work on the final steps of this implementation. First, we are going to visualize the training set results and then we will visualize the test set results. We want to plot the real salaries compared to the predicted salaries. So basically, we are going to have a 2D plot with the x-axis being the numbers of years of experience and the y-axis being the salaries. We will plot the real salaries in red points and the predicted salaries in a blue straight line. Use the pyplot module from the matplotlib, which has the shortcut PLT. Let's define the width and height of the plot in inches. PLT dot figure fixed size, set fixed size to 8,6. By default, matplotlib figures are created 6.4 inches wide and 4.8 inches height. And then call a specific function from this module, which is called scatter. Scatter will allow us to put the red points corresponding to the real salaries in the 2D plot. So PLT dot scatter function. We have to input here the coordinates of the red points representing the real salaries, and these coordinates are X train and Y train. X train Y train. And then we can pass another argument which is color, and which will allow us to choose color of these points. Color equals to, set it to red to display points in red color, and then pass label. The label argument sets the name of the dataset for the entire scatter object. Label equals to data points. Then next step is to plot the regression line. Here we are going to use the plot method called pyplot module. Plot. Input the coordinates of the points. For x, pass x train. For y, pass predicted salaries of the training set. Model dot predict, pass x train. Then to show line in blue color, set color to blue. Color blue. Then assign a name to the regression line using label argument. Label equals to, set it to regression line. This statement will plot the regression line. Then add a title, plt dot title, set title to salary versus experience. Training set. Then add a label to the x-axis and to the y-axis. Add a label to the x-axis. The label we want to display on the x-axis is years of experience. plt dot x label years of experience. Then add a label to the y-axis. The label we want to display on the y-axis is salary. plt dot y label salary. To create legend, use the legend function. plt dot legend function. To display grid lines on the plot, use the grid function. plt dot grid and pass true. To show grid, it will add a default grid lines to both the axes. And finally, to display the figures, called show function. plt dot show. Now we are ready to visualize training set results. Run the cell. So this blue line is regression line, and these points are real data points, real salaries. Next step is visualizing the test set results. Add a new code cell. Copy these statements. Copy this code. Paste here in this cell. Now we are going to write changes in this code, make changes in the second line, replace xtrain by xtest and ytrain by ytest. Color red, display points in red color and label as data points. Xtest and ytest. These are the real observations. We don't need to make changes in this line because regression line that we get is resulting from a unique equation. Now replace training set with test set here in title. Now we are ready to visualize the test set results. Run the cell. These test set points are close to the regression line. Okay, we can see here in this plot, these test set points are close to this regression line. Now next step is slope and intercept. So add two cells. In linear regression model, the slope is stored in the coefficient attribute, COEF attribute. So to find the slope of the linear regression model, use COEF attribute, print slope model dot COEF. Run this cell. Okay, it is 1D array. So we can use here indexing. Now this is slope value. The slope represents the average rate of change. Specifically, it indicates how much the dependent variable y is expected to increase or decrease for every 1 unit increase in the independent variable x. In this case, it is 9423.815. To find the intercept of the linear regression model, use intercept attribute, print model dot intercept. Run the cell. The intercept is the predicted value of y when independent variable x is 0. So in this case, it is 25,321.5830. So our simple linear regression model is able to do a wonderful job at predicting new observations. Congratulations, we have built a very successful first machine learning model. However, just remember that the reason why we get such a good regression line here is simply because there is a linear relationship between the feature, the experience, and the dependent variable salary of the dataset. In the next video, we will build a multiple linear regression model. If you enjoyed this video and want to see more like this, please like and subscribe. If you have any questions or want to share your thoughts about this topic, please leave a comment below. I look forward to seeing you back in the next video. And until then, enjoy machine learning.